I thought we weren't gonna see her today. I thought we had a substitute. Ah, just kidding, guys. Look at the shirt. I recorded this last night. Well, yesterday. You can still see the sun. All right, guys. We are going to be working on 1.11, 1.11, adding and subtracting with scientific notation. Go ahead and title your notes. But wait, this is a recording. But we're recording the recording. Alright guys, today we are going to learn how to add and subtract with scientific notation, as well as ensure numbers are written in scientific notation. Big thing to notate here is if you see a star on this slideshow, that means put it in your notes, guys. Put it in your notes. Alright, now as I quickly relearned how to use this recording on, haha, my pen, on Microsoft PowerPoint, let's do a couple of quick warm-ups. Go ahead and pause this video. Let's go 2 minutes, put this into scientific notation, and then direct message it to the sub when you have your answer. All right, I hope you paused that video because I'm not going to actually give you enough time in my recording. All right, so you should have some answers come in now. Let's take a look and let's see how we would solve this one. So it says, write this number in scientific notation. That means we're going to go from a number in standard form, so a little tiny baby decimal or a big fat number, and we're going to turn it into scientific notation. Step 1, locate your decimal right here. Step 2, locate that spot that's going to be that perfect sweet spot where our number is greater than 1. Remember, x being our number we're trying to find, and it's less than 10. So let's see, our choices here would be 687, 68.7, we could have a 6.87, I know some of you are already screaming, I know it, 6.687, so let's see, that one, way bigger than 10, that one, way bigger than 10, ooh, that one's looking pretty sweet, this one, smaller than 1, it won't work either. 6.87 is our target number. So that is our target decimal place. Now we got to count it. How many places do we need to go back to get from point A to point B? 1, 2, 3, 4, 5, and 6. All right. So we know our exponent's going to be 6. And we know our number is going to be 6.87. Now we just need to decide, is that exponent gonna be a positive? Why did I forget it already? 1, 2, 3, 4, 5, 6. Positive 6 or a negative 6. Give me a second to mull over that one. Now there's a couple things you could do here. You could recognize that we are moving our decimal to the right. That would make it negative. You can also recognize that we're creating a scientific notation for a little tiny baby number. It's a tiny decimal. If it's a tiny decimal, we're taking a negative exponent. So negative 6 is the only logical choice here. And then don't forget to circle your answer. Make your teacher happy. All right. Here's another warm-up opportunity here. Let's just pause the video for 2 minutes and you guys direct message the sub your answers. I'm not going to actually give you the time, so please pause me for a second. All right, now rein it in, rein it in. If you didn't get the answer in, that's okay. Remember, you guys are still practicing with this. This is a totally new skill. So this one we're to do the opposite of what we just did. We need to take this number that's already in scientific notation and we need to turn it into a standard form number. All right, so right there it tells us warm up. Write this number in standard notation. So the things I need to look at here is I need to ask myself, is my exponent positive or is my exponent negative? If my exponent is positive, I'm going to be making a big, giant, fat number. I'm going to be moving my decimal to the right. If this exponent is negative, I'm going to be making a little tiny baby number. Move your decimal Remember, the rules for going from standard to scientific notation or going from scientific notation to standard are exact opposites of each other. So our first step is to write down our decimal number 5. Why is my pen not working? There we go. 5.67. All right, no need to write our scientific notation in that second step because this is the one we're going to use to write our standard form number. So I see here my exponent is 9. That just means I'm going to move my decimal 9 times. Which way am I going to move it? Well, it needs to be a big fat number, and I know to make a big fat number, I need to move my decimal to the right. So that's what I'm going to do. I don't know if I'm coming up mirrored for you guys. If I am, trying to move the right way. You'll see it up here. All right. So I'm going to move it 9 times. That's 1, 2, 3, 4, 5, 6, 7, 8. I ran out of tablet space. 9. That's where our new decimal point will be. What do we fill in all these blank spaces with? No, Taylor, we're not writing names there. We're writing zeros there. 0, 0, 0, 0, 0, 0, 0. All right, so now we have our standard form number. So I'm just going to first write in order all of these numbers I see, and then I have 1, 2, 3, 4, 5, 6, 7. Now they look like eyeballs. 1, 2, 3, 4, 5, 6, 7. And then to chunk this up, make it a little more comprehensible, let's get our commas in there every 3 numbers, and then we can see here that we have $5,670,000,000. Don't I wish? I thought we were done with that stuff. We're not done with this. Actually, math skills build upon each other. So we're going to come back and we're going to practice this one really quick because this is a really important skill. So remember, you put the thing down, you flip it, and reverse it. All right, so you write down the number 1 over 5 to the negative second power. Step 1 is to flip it. Come on, pen. All right, so I am going to put my 5 on top and my 1 on bottom, and then I'm going to reverse it. We're just going to pretend I spelled that right. We're going to turn our negative 2 into a positive 2. Boom. Almost done. Couple more things. One thing is a 1 in the denominator. It's moot. It means nothing. We can get rid of it. Remember, there's that invisible 1 under every number ever in existence. Now we have 5 squared, or 5 to the second power. Let's expand it out. 5 times 5. And what's 5 times 5? Everybody, it's 25. That was a pretty roundabout way to say 25, wasn't it? All right, everybody, shake those hands out. Get ready. We're getting to the nitty-gritty of it. Let's learn how we can add and subtract with scientific notation. And I promise you, it is not as hard as it seems. All right? It's not as hard as it seems. So breathe. Let's go to the next slide. So the number one thing you're going to need for this lesson is a review of the distributive property, because we use the distributive property in adding and subtracting with scientific notation. In fact, it is the backbone of the entire process that we're going to do. So let's do a quick little review. Let's look at this. We have negative 3 parentheses, 5 plus 2, and then close parentheses. All right. We need to distribute. That is the first thing we do. Now, we could add together that 5 plus 2, but we're just going to pretend that we don't see that, and we're going to distribute our 3. And then we'll see what happens when we just add those 2 together. So first, I'm going to distribute my 3 into my 5 and into my 2. Excuse me, my negative 3. Don't lose that negative. It makes everything it touches negative. All right, so first is negative 3 times 5, and that's just going to give me a negative 15. To that, I'm going to add my negative 3 times 2, and that's going to give me a negative 6. The beautiful thing that happened here is these are both negative numbers, which means we can add them together just like they're regular numbers. 15 plus 6 is 21, but they're both negative, so I know it's negative. Circle it to make your teacher happy. But wait, there's more. What happens if we just add those together on the inside? The way that we think we're supposed to do it, the way PEMDAS tells us to do it. Let's do it that way. 3 on the outside, either parentheses, crazy lady. 5 plus 2. So if I were to go ahead and add those together, my first step, 5 plus 2 is 7. And I'm going to put that back in its parentheses, and then I'm going to realize that I am now in algebra, which means parentheses are the same thing as multiplication, just like we did over here on this side. All right, so what's 3 times 7? 21. Negative times a positive. Negative. Look at that. Beautiful. Same answers. Okay, so understanding how to manipulate and redistribute the distributive property is paramount to understanding what we're going to do next. Now, repeat after me. I will put this in my notes. I will put this in my notes. This is so important. I will put this in my notes. I promise, teacher lady. Okay. When we are adding and subtracting scientific notation, they must have the same power of 10. Doesn't matter what your decimal is. The number attached to the front, that's what we're going to actually add and subtract together. But the exponent attached to the base 10 must be exactly the same. Exactly the same. Like this. Where is my cursor? There she is. Like this. 7 and 7. Those are the same number. Down here in the X category of no good are 10 to the 5th and 10 to the 7th. Those do not have the same power. Let's look at some more examples that have the same power and don't have the same power. Why 10 to the 3rd and 10 to the 3rd? Those are good. Those are friends. They will work. But what if we had 10 to the 5th and 10 to the negative 5th? No. No. Those are not the same. They will not work. The power of 10 must be exactly the same. You wrote that down by now. I'm so proud of you. Pat yourself on the back. All right. Now let's take a look at the process that we do take when we are adding and subtracting with scientific notation. The process is going to be exactly the same whether we add or subtract. The only difference will be what operation we do, if we add them or subtract them. So let's take a look at this. Now before we go looking down at the bottom here, let me pull up my laser pointer real quick so you can see where I'm pointing at. Don't look at all this yet. Let's look up at here. Let's look at what they're giving us, okay? They're giving us 1.63 times 10 to the 7th plus 2.4 times 10 to the 7th. So first we need to check. We need to confirm that these have the same power of 10. Because remember, OLS likes to throw nonsense at you sometimes and give you that no solution choice. Be careful. All right, so 10 to the 7th, good to go. 10 to the 7th, also good to go. Now we apply the distributive property. How can we do that? Well, if you look here, within our parentheses, these are both being multiplied by the same number. Okay? We could replace this whole thing and multiply these both by 5 and use the distributive property the same way. Nobody would do that because it would be super confusing, but it's necessary when we're using scientific notation. So 10 to the 7th and 10 to the 7th, we can redistribute that. We can say, if we add our decimals together, we can multiply that whole thing by 10 to the 7th, and the solution will be the same. Okay, we can actually work all this out on a calculator, and you will see you don't even really need a calculator for half of it, and you will see that those answers will be exactly the same, just like I showed you in the previous distributive property. So after we add together our 1.63 plus 2.4, we end up with 4.03 times 10 to the 7th. And that's it. That is your answer. You're going to express these answers in scientific notation. That's the whole point of scientific notation, is to actually make things easier, not harder. But there's something you need to watch out for when you add these together. You need to confirm that your new decimal follows that rule of being less than 1, or I mean being greater than 1, but less than 10. If it doesn't, there's an extra step we have to take. But in this case, it all worked out. And right here we see a case of that very thing happening. All right, let me switch back to laser pointer real quick. All right, so let's not look at any of this. If we were live in class right now, I would be putting a blockade over this stuff. But I either can't or don't know how to do that when I'm recording a video. So moving right along. Follow the red bouncing dot. Up here. All right. So these steps we already know how to do. We already looked at this before. We need to add 3.4 times 10 to the negative fourth plus 9.05 times 10 to the negative fourth. So first we need to confirm. Do they have the same exponent of 10? Negative fourth power, negative fourth power. Those are exactly the same. I am good. I can move on with my steps and complete this problem. All right, so we need to apply the distributive property first. We just apply the distributive property, and we're going to add together our 3.4 and our 9.05. If you're missing what happened in that step, let me go ahead and pen that in right here really quickly. What happened there is that step was where we went 3.4 plus 9.05, and we're calling that whole thing multiplied by 10 to the negative fourth. All right, and that's where we arrive at 12.45 times 10 to the negative fourth. But unfortunately, this is not scientific notation. 12.45 does not follow the rule of being between 1 and 10, because remember, this number here must be greater than 1, but less than 10. Okay, and remember all this says is 1 is less than x is less than 10, if we just read it like a sentence. I'll make that 1 look more like a 1, less like the line of a K. All right, so 12.45. Can't do it. Not going to work. But we can rewrite this in scientific notation by taking an extra step. All right? Now, this is what is actually going on in here. Okay? We want to move this. Why did my cursor go crazy? We want to move that one space to the left. Okay? Which would be a factor of 10 to the first power. All right? So, if we want to make this 1.245, we need to multiply that by 10 to the first power and then 10 to the negative fourth power. Now, remember those properties of exponents that we talked about last week? When we multiply the exponents with the same base, we add the exponents. So we would go 1 plus negative 4, which would give us negative 3. So our answer here is 1.245 times 10 to the negative third. I can draw on myself? Oh my goodness. I'm going to give myself red hair. If I don't move, now I have red hair. All right, guys, let's take a step into the world of subtraction. All right, and let's look at what happens when we subtract. Now, this is a really basic example. This is a more simple example, but it's the same steps we take when we are adding. We're going to do the same thing when we subtract. So first, we're going to confirm that our power of tens are the same. Let me pull out my laser pointer real quick. Up here, I have a 10 to the 10th power. Over here, I have a 10 to the 10th power. Oh, 10 and 10, those are the same. We can move on. We can complete this problem. Now, the next thing we need to do is we need to use the distributive property to smoosh our 7.8 and our 1.9 into the parentheses together. We're going to subtract them this time because this is a subtraction problem. And then we're going to multiply that by our power of 10. So let me get some arrows in there so you guys can see what happened here. Boom, boom. And then for the last step, all you need to do, either do it by hand or put it in your calculator. 7.8 minus 1.9 gives me 5.9. And our answer would be 5.9 times 10 to the 10th. Last thing you definitely want to double check though is you want to confirm that your answer is in scientific notation. So you need to look at that rule. Is it greater than 1 but less than 10? All right, so is our number is 5.9 greater than 1 but less than 10? Yes, it is. Our answer is in scientific notation. And now we're recording this for the third time because I can't figure it out. I just don't know how to move myself, guys. I just don't know. I'll write the answer over here so we can all see it. I'm done trying to figure out how to make Miss Hill a little bit smaller. All right, let's take a look at this next problem. Now, this is where it gets a little bit trickier. All right, so we have 5.5 times 10 to the negative 8th minus 4.9 times 10 to the negative 8. Negative 8, negative 8. We are good. We can subtract these. So we just take that step we just learned where we smoosh them together with the distributive property. They did skip a step here, but I think we're good on that step. We just went 5.5 minus 4.9, and we ended up with 0.6. So we have 6/10 times 10 to the negative 8th power. But your warning signs should be going up right now because this is not scientific notation. But why? Why is it not scientific notation? Because we all know by now that to be scientific notation, our number must be... Everybody's saying it. Ooh, look at how messy that is. I'm just going to make it a little bigger. It must be greater than 1 but less than 10, and this is less than 1. It's no good. So we need to do the opposite of what we did before. We need to do the opposite of what we did for the addition. We need to figure out what do we need to do to this bad boy to make him between 1 and 10. And that's going to be moving the decimal one place to the right. When we move it one place to the right, okay, that's going to be a negative 1. So now we're going to need to multiply this whole thing by negative 1. When we multiply same base exponents, we add their exponents. And now for the big reveal, since you can't see it back here. Our final answer will be 6 times 10 to the negative 1 plus negative 8. That's negative 9. And then we circle it. That's what it says behind my room there. Where it says responsibility, it's supposed to say negative 9. All right, got a couple more practice problems coming your way. We're going to work these two out, and then it's going to be time for your exit ticket. All right, let's do this. I just took a little break in case you were wondering. But how would you know? Because this video is just clipped together. All right, guys. Let me grab my pen. And first, I need to fix this expression because it's wrong. It's missing its parentheses. All right. Now we can tackle this bad boy. All right, we need to add these, this scientific notation. And what is the first step? If you said distributive property, you're wrong. We need to make sure that it has the same exponent first. 5 and 5. All right, now if you said distributive property, we're good. That's what we do first. So I need to redistribute with the distributive property my decimals together into a parenthesis, and then onto that I need to add my, or multiply by my 10 to the 5th power. All right, what's going to go inside my parenthesis? Why, my 2.9 plus 8.7. All right, and I'm going to switch to my pen. I was just doing that with my mouse. Now in this next step, we need to add together what is inside of the parenthesis, and I have been working for about 12 hours today. I'm exhausted because right now today is yesterday, and yeah, let's not go there. We're just gonna all confuse ourselves. Okay, so I have 2.9 plus 8.7, and that gives me 11.6. 11.6 times 10 to the 5th power, and I'm done, right? No, I'm not done. Why am I not done? Somebody chat it. Yes, if you chatted that because that is not scientific notation, thank you, pat yourself on the back. Alright guys, because 11.6 doesn't follow the rules. As we can see, our decimal in our scientific notation needs to be greater than 1 and less than 10, and 11.6 is greater than 10. Alright, we need to do some fancy footwork here, and I'm going to need to go grab a different color marker. Because what we need to do is we need to get this decimal right there. If it were right there, then we would have 1.16. And 1 and 16 hundredths is absolutely in between 1 and 10. Or, you know, where it's greater than 1 but less than 10. So, how did we get there? How do we get from 11.6 to 1.16? What did we pull out of that? We pulled out a whole 10, right? Because if I take this and this one, 11.6, and I divide it by 10, I will end up with that. Well, what is 10 but 10 to the 1st power? Because remember, every whole number has that 1, that exponent of 1 hanging out. There's invisible ones all over math. And you have to learn all the places they're located. Alright, and then we need our 10 to the 5th power. We're almost done. We just need to take the last step to simplify this, and then we are golden. Alright, so I have a base 10 exponent, I have a base 10 exponent. If I am multiplying two exponents with the same base, I can add their exponents. This will become 10 to the 1 plus 5 power. Don't get ahead of yourself, we'll do that in a second. And then let's bring down all the junk we have not used yet. I'm kind of liking this blue. I wish I would have discovered it earlier on in this presentation. All right. So, last step, yes, add 1.1 plus 5, and we're done. So we have 1.16 times 10 to the 6th power. All right. Circle your answer to make your teacher happy. We're not quite done yet, though. I'm going to use this guy here as an example as to the why all this works. This is your proof. So, the first thing we're going to need to do is we're going to need to expand this scientific notation right here. And we're going to compare the expanded answer we get here to the expanded answer we get when we expand these two scientific notations in the original problem separately. So, I have 1.16. I know I need to move my decimal 6 times because it's multiplied by 10 to the 6th power. I'm just going to grab another color over here now that I know where they are. I'm going to move this 6 times. 1, 2, 3, 4, 5, 6. What do I do with my blank spaces? That's right, I add zeros. 1, 2, 3, 4. So my answer for my expanded version over here will actually be 1, 1, 6, 0, 0, 0, 0. Get in my commas, 1,160,000. Let's see if we get the same answer on the other side if we expand it right off the bat. So for the first one, I'm going to do 2.9. I'm going to do it way up here just so I have enough room to do both of them. So I'm up in the green right now, guys. 2.9 times 10 to the 5th power. I have my 2.9. I know I need to move that 5 times. So I'm going to move it 5 times. 1, 2, 3, 4, 5. Add in my zeros. So over here I have 290,000. It's 290,000. All right. And then for the other one, let me just circle it so I don't lose that. I have 8.7 times 10 to the 5th. So 8.7, and I'm going to move that 5 times. 1, 2, 3, 4, 5. So that'll be another 4 zeros here, which will give me 870,000. All right, so now we have our two numbers that we need to add together. So we need to add together 290,000 and 870,000. And now you can kind of see the amount of work you have to keep track of and why scientific notation is kind of useful. So just so no one knows I'm fooling ya, 290,000. There's our 290,000 plus 870,000 1,160,000. 0, 0, 0. Boom, exactly the same. Man, I know I say this constantly, but I really need to proofread these slides. There we go. I feel much better now. All right, so let's do one practice problem dealing with subtraction. You will be pleasantly surprised with this one. It's going to take a lot less steps than that last one we did. All right, so first things first, we need to confirm that we have the same power of 10. -3. -3. We are good. We can move on. All right, so I have 11.3 times 10 to the -3rd minus 6.7 times 10 to the -3rd power. So let me redistribute that. I have my parenthesis, my 11.3. To that, I'm going to subtract from that. Sorry for that grammatical mistake. 6.7. And then the whole shebang is multiplied by 10 to the -3rd power. All right. Now, your radars should have just been alerting you at the very beginning that part of this is not in scientific notation, but that's okay. We are just going to complete the problem anyway. They could have, there's lots of stuff you can do with this. We're not going to get into that stuff. You will learn it in high school. But right now we're going to deal with our 11.3 minus 6.7. 11.3 minus 6.7. Yes, I am still exhausted. 4.6. 4.6 goes inside our parentheses, and by that we add our 10 to the -3rd power. Are we following the rules? Are we in scientific notation? We sure are. We are greater than 1 and less than 10, multiplied by 10 to the -3rd. Now, my last question for you before I let you go. Is this going to be a big fat number or a little tiny baby decimal? And why? Chat it to the sub right now. It's a little tiny baby decimal. I know that because my exponent is negative. So let's just go ahead and expand this for the practice. So I have 4.6. And I'm expanding this. I'm going to the -3rd power, which means I'm going to go to the left. So I'm going to go a 1, a 2, a 3. I'm going to place my decimal point right there. Add that leading 0 because you always have a leading 0 in front of your decimal. And then fill in your blank spaces. Now we have 0.00000. or tens, hundreds, thousands, 10,000s. I'm very tired. 46 10,000ths. Boom, boom, boom. So here's your scientific notation answer. Here is your expanded answer. All right, guys, here is your to-do list for today. Complete Unit 1, Lesson 11, including all those practice problems. Some of them we did in class. Some of them we didn't do in class. Be sure to practice with the skill because the only way to master math skills is practice. Exit tickets coming up. All right, guys, it is exit ticket time. Now, we are not going to go over this until tomorrow. Don't worry, I do not expect the sub to go over this problem with you, but you do want to write this down because this will be our warm-up for tomorrow, and we will go over it in detail if you were stuck on it in any way. All right, you guys can work together in groups on this. If you know how to put them into table mode, be my guest. I think you guys are set for 5 per table. And put this in your notes. Express your answers in scientific notation. I will not complain if you expand this and give me the expanded form as well. But tell me this. What is 6.75 times 10 to the negative fourth minus 2.38 times 10 to the negative fourth? Confirm your exponents and have at it. I will see you guys tomorrow. Right up next, you're going to have ELA. You guys are going to read the first chapter of Frederick Douglass. Be sure to go over those vocabulary terms in ELA. They've already been added to the Google Class Resource folder, vocabulary for Unit 1. And let me know if you have any questions. Have an absolutely beautiful rest of your day, and I will see you tomorrow, guys. Bye!